Today we are going to solve quadratic equation problem 2019 past pay. This is the problem. First they are given range of value to the p and show that 1 is not a root of the equation p squared x squared plus 2x plus p equals c. If 1 is root of this equation, then it must satisfy the equation. Let's check. Equation is p squared x squared plus 2x plus p equals 0. I am going to substitute 1 into the x. Then p squared into 1 squared plus 2 into 1 plus p equals 0. Final form p squared plus 2 plus p equals 0. Now we are going to check whether this is 0 or not. First they given that p is range of this. P is greater than 0, it means p is a positive value. So if p is a positive value, we can see there is a three terms p squared plus 2 and p. If p is a positive, then the p squared is definitely positive. 2 is positive. Then third term is also positive. So the addition of three positive numbers never can be a 0. So we can say that 1 is not the root of this equation. Then second, they want to show that they said that alpha and beta are the roots of this equation. Show that alpha and beta are both real. To find the nature of roots, we have to find the value for the discriminant. If the discriminant value is greater than or equal 0, then the roots are real. We know that. So I am going to check the discriminant value. We know that discriminant equals to b squared minus 4ac. Here b squared is 2, then 2 squared minus 4. A value is p squared. C value is p. I am going to expand 4 minus 4p keep. I am going to take 4 out, then 1 minus p keep. I can factorize this. This is the difference of 2 cubes. Then I can write it as this: 1 minus p into 1 plus p squared. As you can see, 1 minus p is positive or 0 when p is in the given range. Right? This can be positive or 0. If it is 0, discriminant is 0. It is a valid condition. If it is not 0, then 1 minus p is a positive value. We know that 1 plus p squared is definitely positive. So the discriminant is definitely greater than or equal 0. Then the roots are real. Let's move to the next part. Then we have to write down alpha plus beta and alpha dot beta in terms of p and have to find some expression. First, write the alpha plus beta and alpha dot beta. The equation is p squared x squared 2x plus p equals 0. Now I am going to, given that the alpha and beta are the roots of this equation. Now I am going to write alpha plus beta, which equals to minus b divided by a, in this case minus 2 divided by p square, and multiplication of roots c divided by a, in this case p divided by p square, which means 1 over p. Now I am going to find the expression for given. We have to find expression for the 1 into 1 divided by alpha minus 1 into 1 divided by beta minus 1. First I am going to expand. So 1 into 1 is 1. Alpha into beta means alpha beta. Alpha into minus 1 minus alpha. Minus 1 into beta minus beta. Minus 1 into minus 1 plus 1. Then I can take negative mark out from the minus alpha and minus beta, and it becomes alpha plus beta plus 1. Now I can substitute terms. I have 5. 1 alpha dot beta, I got answer for the 1 over p, minus alpha plus beta is minus 2 divided by p squared and plus 1. Now I am going to take common denominator. That's this. P squared is the common denominator. Then this term becomes p, minus 2 into minus 2 plus p plus p square. We know that this term is multiplied by 1. Then I can finally obtain the given expression as this p squared plus p plus 2. This is the expression we have to obtain. We have successfully achieved it. Next, move to the next part. Then we have to find the quadratic equation whose roots are alpha divided by alpha minus 1 and beta divided by beta minus 1. And both these roots are positive. Okay. So we have to find the quadratic equation whose roots are alpha divided by alpha minus 1 and beta divided by beta minus 1. I can write quadratic equation as this. I know the roots, so I can write it as this, minus addition of roots. It means alpha divided by alpha minus 1, beta divided by beta minus 1 into x, plus multiplication of roots alpha minus 1 dot beta minus 1 equals 0. So if we find value for the addition of roots and multiplication of roots, we can find the quadratic equation. So I am going to find these values. First I am going to find value for the addition of roots. Alpha divided by alpha minus 1, beta divided by beta minus 1. I am getting common denominator as alpha minus 1, beta minus 1. And alpha is multiplied by beta minus 1 and beta is multiplied by alpha minus 1. Now I am going to expand alpha beta minus alpha plus alpha beta minus beta divided by alpha minus 1 beta minus 1. I can simplify this. Alpha beta plus alpha beta is 2 alpha beta. I can take negative term out of minus alpha and minus beta. Then it becomes alpha plus beta. And alpha minus 1 beta minus 1. I can express this final form in like this. 2 alpha beta minus alpha plus beta, this whole term multiplied by 1 over alpha minus 1 into beta minus 1. I am going to substitute values. 2 alpha beta means 2 we got alpha beta as 1 over p minus alpha plus beta is minus 2 divided by p square, and whole term I am going to multiply by value we found. Square bracket this. We got this value early in the problem. We got this value as p squared divided p squared plus p plus. Now I am going to simplify, take in common denominator as p squared, then this term becomes 2p plus 2 into p squared plus p plus. Here p squared dot. I can take 2 as common term, then p plus 1 p squared p plus, here p plus 2 p plus. Okay, I obtained the expression for the addition of roots. Now I am going to take expression for the multiplication of roots. Alpha minus 1 into beta minus, which I can write as alpha minus 1 beta minus 1. I am going to substitute value as alpha beta. I get value as 1 over p, and this value we obtain in the problem as p squared divided by p squared plus p plus 2. So 1 p is going to drop. Final value I can obtain as p divided by p squared p plus 2. I am going to substitute this value to my quadratic equation. X squared, addition of two roots is 2 into p plus 1 divided by p squared p plus 2 into x, and multiplication of two roots p divided by p squared plus p plus 2 equals 0. Now I am going to multiply whole equation by p squared p plus 2 and obtain in my quadratic equation. P squared plus p plus 2x minus 2 into x squared minus 2 into p plus 1x plus p equals 0. Okay, we obtain our quadratic equation. Now we have to solve these two roots both are positive. So to show that, I am using additions of two roots and multiplication of two roots. So I take addition of two roots, alpha minus 1 plus beta divided by beta minus 1. We obtain this as 2 times p plus 1 divided by p squared p plus 2. Since p in range of, we know that p is greater than 0 and equal or smaller than 1. So in this range, p plus 1 is a positive term. So the numerator is always positive. And we know that p squared plus p plus 2 is also positive. So I can say the additions of two root is positive for sure. When I consider the product of two roots, alpha divided by alpha minus 1, beta divided by beta minus 1, we get value for the p divided by p squared p plus 2. So we know that p is a positive number, and this value also positive for sure. Then the multiplication of two roots are definitely positive. Since the addition and the multiplication both are positive, we can say that both roots of this equation is positive. This is how we solve the quadratic equation completely, step by step. In next video, I am going to talk about quadratic equation problem in 2018 paper. See you at next video.